Hey everyone, this is the very last video in our Chapter 6 series where we've been talking about mechanisms and carbocation rearrangements. So if you remember, the very first video we talked about SN2 reactions and mechanisms, then we talked about SN1, and then we started talking about carbocation rearrangements, so that includes the hydride shift, the methyl shift, and this is the very last video where we will be talking about, unfortunately, ring expansions. All right. So a lot of people find ring expansions challenging. Hopefully this video will put some of that to ease. So we'll see what happens. So this is the last kind of carbocation rearrangement we can have. There's three. This is the third. All right. So, and again, I'm going to be assuming that we have some baseline knowledge of SN1 in this video. So if you are lacking in that baseline knowledge of SN1, I would either watch the video on SN1 or do some review on SN1 before you watch this video, just that way you don't confuse yourself. Okay. So what I'm going to be doing is I'm going to be starting with this 4-member ring that is attached to a chlorine, and then there's also a methyl group right there. Okay. So a bit of a weird substrate to be starting with, but there's reasons behind it. And then we also have water that we're going to be putting this through. It's just simple to put it through water, so that's what I'm going to do. And then our product that we're going to be showing how we got to is going to be this one. Okay. And I'm not going to worry about stereochemistry in this one. Like, technically, we would get the OH on a wedge and on a dash, right? Like we would get two products. I'm not going to worry about that too much. I think that that's just overly confusing for this video, so I don't want to worry about that too much right now. But yes, if you're wondering, yes, you do get both. Okay, but we're not going to be too concerned about that for this video. Okay, so here we go. Let's start doing the mechanism. So remember that the very first step in a SN1 mechanism is that the leaving group leaves, right? So chlorine is going to leave. It's going to get out of there. And then what do I form? So I form this, and I form a carbocation here. And then I also get my Cl minus, right? Okay. And then this is gonna do something. Okay. Excuse me. So what's going to happen now is that our ring expansion is going to occur. Why? Because this 4-member ring is unstable. Okay. Just know that 3-member rings, 4-member rings, and 5-member rings are unstable. The lower the amount of carbons in a ring, the more unstable it is. So 3-member rings are very unstable. 4-member rings are pretty unstable, but they're not as unstable as 3-member rings, and so on, right? The most stable is 6-member rings. So things prefer to be in 6-member rings if they can. So 3 will turn into a 4, and a 4 will turn into a 5, and a 5 will turn into a 6. Okay, so in this case, this 4-member ring is going to want to turn into a 5-member ring if it has the ability to, and it does. So on the adjacent carbon here, okay, this adjacent carbon, what's going to happen is this bond is just going to move to this carbocation, okay? And what I'm going to do is I'm going to number my carbons. 1, 2, 3. I'm going to say this is 4. Carbocation's 5. This is 6. And then my methyl group here is 7, all right? So now I'm going to draw my 5-member ring, and hopefully we can kind of see where everything is gone now that I've numbered the carbons, all right? It's a bad drawing. Let's try again. Beautiful. Okay, so this is 1, this is 2, this is 3, and then we have carbon number 4, which is going to be here, right? And then on 4, I have a methyl group, which is carbon 7, right? So this is 7 right there. And then next to 4 is 5. And 5 is attached to carbon 6, which is that methyl group. Okay, so this is what's going on. So now my question is, where is that positive charge? So look at it this way. 5 is not going to have a positive charge anymore. Why? Because it just gained a bond, right? This bond from 3 to 4 broke and reformed at 3 to 5, okay? So 4 just lost a bond, right? Carbon 4 just lost a bond. So that means that my positive charge is going to be here on carbon 4. Okay. And if that doesn't make sense, I would really look at this. Okay. I would really look and see what's going on. Literally, all that's happening is that there's a shift. Like now I've formed the bond here. Okay. So originally the bond was here. So this dashed line is where the bond used to be, but now I've formed the bond here. Okay. So now carbon 5 has that bond, and carbon 4 just lost a bond. So carbon 4 is like, what the heck? Now it has a positive charge. All right. Okay, cool. So this is my ring expansion. Okay. So I'm going to write ring expansion. I'm going to write ring expansion over the arrow, and now everything just continues as it normally would. Okay. So again, everything's a little cramped because of my numbers, but that's okay. Water is going to come in. And also, just to be clear, you don't have to write the numbers on an exam. I just wrote the numbers for clarity's sake here, so that way if you had trouble seeing what was going on, I wrote the numbers just so that we could kind of see what was happening. So water comes in, acts as a nucleophile, and it attacks, right? And then we have a positive charge here, and then another water is going to come in, and it's going to take the hydrogen off there, and those electrons are going to go there, right? And then after that, I am done. So we have OH there, and then we have H3O plus. That's my byproduct. I'm done. That's it. See, ring expansions are so easy, right? No, not really. They're not super easy, but just so you know, this is how it happens, right? There is 2 more that I want to cover. I hope that we have enough time to cover here. I don't want this video to be too long, but there's 2 more things that I want to cover as far as ring expansions go. So let's see if we can take a look at the next thing that I want to cover for ring expansions. Get a little bit more room. So we're still talking about ring expansions. Okay, ring expansions. So this time I'm gonna have a 5-member ring that is going to be going to a 6-member ring. Okay, 5-member ring to a 6-member ring. Not too bad. And again, I'm just going to use water. Okay, like you can use methanol, whatever, right? I just want to use water just to make this slightly easier on everybody. Don't want to make this too infuriating. It's just my product. And then we can go ahead and do the reaction here. So in this one, there's going to be a slight caveat. That's why I wanted to do this one. In the one I'm going to do after this as well, there's also going to be a slight caveat. All right. So just be prepared for that. Okay. If you remember in the Hydride Shift and Methyl Shift videos, we talked about those. I talked about a primary alkyl halide and what happens with a primary alkyl halide whenever there's a shift that occurs, right? Primary carbocations cannot form. So that means that if I had the chance of forming a primary carbocation, the shift is going to occur at the same time that the leaving group leaves. So when bromine leaves, right, it's not even going to have the chance because this bond is going to shift here to where my carbocation would be, which is going to cause bromine to leave. Okay, otherwise bromine can't leave because the primary carbocation does not want to form because it's very unstable. So in the case of this, where I have a primary alkyl halide, my shift is going to occur at the same time. It's the very same thing with a hydride shift or a methyl shift. My shift occurs at the very same time. Okay, so here the same thing happens. Shift occurs at the same time. So now very quickly, let's just number our carbons. 1, 2, 3. Call this 4, this 5, and this 6. I know I've numbered it a little strange here, but I think that it'll get the message across. So now I'm going to say that this is 1, this is 2, this is 3, this is 4. And actually, sorry, I'm numbering wrong here. I've drawn it here, so I'm going to say that this is 4. So this is 3, this is 2, this is 1, this is 5, this is 6. Okay. So this is how I'm going to number this here, okay? So in this case, the numbering is not a huge deal because like you can really put this anywhere on here, right? But just for clarity's sake, I just want to kind of have these numbers here. So the bond from 3 to 4 broke, right? 3 to 4 bond broke. So 5, the charge on 5, there is not going to be a charge on 5, right? 4 just lost a bond. So there's going to be a positive charge on 4 because 4 just lost a bond. Okay. That's all I'm doing. All right. That's all I'm doing. So now that I've done my ring expansion, my SN1 reaction is just going to continue as normal, right? So water is going to come in and it's going to attack the carbocation. And then I'm going to get this intermediate, right? I have a positive charge here. And then another water is going to come in and it's going to take that hydrogen off, and those electrons are going to go there. Okay. And let me also say right here, I forgot to mention this, and I think this is important. Right here, bromine left, right? So I'm also getting a Br minus. Okay, that's important. We don't want to forget that, right? We also have a Br minus that was formed here. Okay, sorry, I forgot to mention that. Little scatterbrained. Anyway, so water's going to come in. It's going to take that hydrogen off. And then we are going to go to the end product, which is OH there. And then we also get hydronium, H3O plus. I'm done. That's it, right? So again, nothing too terrible. I just wanted to show an example with a primary alkyl halide so that way you can kind of see what goes on, that the shift must occur at the same time as the leaving group leaving, okay? So that way we don't allow that primary carbocation, which is highly unstable, to form, okay? All right, now we're gonna do one last thing, but there's 2 things I'm gonna mention in this last problem, okay? So bear with me here. I don't want this video to be too long, so 1 or 2 things I'm gonna mention here. We're gonna do one last example. So the example that I want to do is, we'll do another 4-membered ring. We'll do 4, and I'm going to actually move this down. We'll do another 4-membered ring. And I'm going to do a 4-membered ring to a 5-membered ring, right? And then, so this is 1, 2, 3, 1, 2, 3. So then here is where my methyl group would be. Sorry, I'm having to like work ahead and everything. So that way I can kind of tell what's going on. So this moves up and then our OH should be here. All right, we'll check that whenever we draw the mechanism, right? If the mechanism doesn't check out with what we just drawn, then we know that we may have messed up, right? But I think this should be right. Okay, so here we go. Drawing the mechanism. All righty. So chlorine, this is a 2-degree alkyl halide, right? So chlorine is free to just leave. So chlorine's going to do that. It's going to leave. Okay. And then, so we get the cyclobutane, with a positive charge here. And again, I'm going to number everything. 1, 2, 3, 4, 5 with the chlorine, 6 here. And I'm going to do the same thing here. 1, 2, 3, 4, 5 with the positive charge and 6 here. Okay. So now, and I also get chlorine minus. Let me draw that really quick. So now what's going to happen? Well, I get my shift again, right? I get my ring expansion just like last time. So my ring expansion, my bond is going to move up there. I'm going to get my ring expansion. So after that happens, then I get my 5-membered ring. Okay, so now I'm going to number the 5-membered ring as well. Okay, so 1, 2, 3, and then 4. And then 5 is attached to that methyl group, right? So 5 is attached to that methyl group, okay? So remember 4 is the one that lost the bond, right? 4 lost a bond. So since 4 lost a bond, the positive charge is here on 4, okay? And I'm, for a reason, I'm gonna move everything over slightly. So 5 is here, 6 is here, right? And then my positive charge is here on 4. Okay, very good. So now, this is a 2-degree carbocation right here, right? Remember, I started with a 2-degree carbocation. So have I really increased the stability of anything? Not really, right? The ring is more stable. So like this is a more stable compound. But the problem is that you'll notice that this carbocation can rearrange again, right? I could move this positive charge here, and then that would give me a 3-degree carbocation, right? So how would I move it here? Well, the way I would move it here would be that this hydrogen, I can take this hydrogen and I can move it here, right? What's that called? Hydride shift, right? So if I have a hydride shift, then we already know how to do hydride shifts, right? All that's going to happen is my positive charge is now going to be right here on this carbon, okay? And let me move it slightly closer to that carbon just so that way we're following what's going on here. All right, so positive charge there. So now I can't, there's no way to move this positive charge to make it on a higher degree. So this is more than likely the most stable carbocation I can make. So now I can continue with my reaction as I normally would. So H2O is going to come in. And we're going to go through these last steps very quickly. And then I have my 2 hydrogens on OH, that plus there. Another water is going to come in. It's going to take that hydrogen off, which is going to give me my very final product, which looks like what we just drew earlier. And then I also get hydronium. And I'm done, okay? So the reason I wanted to do this example is that in a ring expansion, okay, after you do the ring expansion, you're not always done. Okay, so the 2 examples we did before this, we were done after we did the ring expansion, right? Because it was the highest degree that it could be. But in this case, a hydride shift could occur after the ring expansion. Now, of course, it's also possible that a methyl shift could occur after the ring expansion. And the way that would happen would be, and I'm going to draw this very, very, very quickly, just so that way we kind of know. I don't want this video to be a million years long. So if we had something like this, okay, and chlorine leaves, right? So chlorine leaves. This is an example of a methyl shift in a ring expansion, okay? So chlorine leaves, and then I get my positive charge here, right? So then this bond is going to move up here, right? And then I also get Cl minus. So I get my other ring expansion. So let's write that over the arrows. This is my other ring expansion. Okay. So then I get my ring expansion to my 5-membered ring, okay? And 1, 2, 3, 1, 2, 3. So 4 lost the bond, right? So positive charge here. But then remember, on this one, I have 2 methyl groups now, right? I don't have a hydrogen on that anymore. I have 2 methyl groups, okay? So one of these 2 methyl groups is going to move. So we'll say one of these methyl groups moves over here. And then whenever that happens, that is a methyl shift. Okay. So that's my methyl shift. And then what do I get after that? Well, I get my positive charge here, right? So now my reaction can continue as normal. So we'll just say the nucleophile is water in this case. So water is going to come in. It's going to do that. I'm going to attack on the positive charge, right? And then we get our O with 2 H's and that and the positive. And then we also have the water that's going to come in and it's going to take the hydrogen off. And those electrons are going to go on the oxygen, right? So now I'm done. This is my final product. And then I also get hydronium. Okay. So I know that was probably a lot of fun for everybody, but 3 things I wanted to cover in this, right? I wanted to cover a basic ring expansion that didn't have any caveats with it. And then I wanted to cover the ring expansion where you can have that primary alkyl halide, so the ring expansion has to occur at the exact same time that the leaving group leaves. And then I also wanted to cover this as well, where you can have a ring expansion, and then after the expansion, you can have either a hydride shift or a methyl shift after the ring expansion. Okay. It's also possible that you have like another ring expansion after the first ring expansion. We're not worried about that. Okay. That is not a concern of ours at all. So it's just something that is possible. Okay. So I think that's everything that is important to cover in here. I would certainly do some practice problems whenever it comes to ring expansions and all that, so that we can kind of understand exactly what's going on. But again, hopefully this was helpful. And this is the end of chapter 6 now. We're done. So I'm glad you tuned in for all the videos. Hopefully you tuned in for all the videos, right? And if you didn't, check out the other videos. And I will see you for the chapter 7 videos in our next one. So I very much appreciate you watching, and I hope you have a good one.